in this video, we're going to look at factoring again. Only this time we're going to look at what happens when we factor the difference of two squares. Now, remember that the word difference means subtracting, because this rule that we're going to talk about only works when you are subtracting. So what happens if we want to factor out a squared minus b squared? What are we looking at? What we're really looking at here is this. A plus b times a minus b. Now, how do I know that? Because what I want is for my answer after I factored to cancel out my middle terms. So watch what happens. When I use my FOIL method, a times a gives me my a squared. A times negative b gives me a minus ab. And I'm going to do my second term. B times a gives me a positive ab, and then b times negative b gives me a negative b squared. So when I go back to combine my like terms, I'm going to find that I'm going to have a squared, then I have negative ab and positive ab. Those simply cancel out, and then I get a minus b squared. So here we have factored the difference of two squares. So let's look at some more examples. Here I have x squared minus 64. So I'm going to go ahead and put my two sets of parentheses. I know I have to start with x. So what's my other number? My other number, what's 8? The square root of 64 is 8. So we're going to put 8 here and an 8 here. Now remember, I want my middle terms to cancel out. So I need a positive 8 and a negative 8. And if I go back and check it using FOIL, I'm going to get x squared minus 8x plus 8x minus 64. Well, when I cancel out and combine my like terms, I'm left with x squared minus 64. Okay? So let's look at another one. This time I have a coefficient with my first term, but that's okay. I'm still going to take the square root of each term. So square root of 25 is 5. Square root of x squared is x. So I have 5x. Square root of 81, 9. So I'm going to have 5x plus 9 and 5x minus 9. And if I were to go back, FOIL it through, I would come back to my answer I began with. 25x squared minus 45 plus 45 minus 81. Whoop, there should be x's on both of these. And of course, this and this will cancel out. Okay, so let's look at another one. This time, I have variables and coefficients in both of my terms. Does not affect how you solve the problem because you still want to take the square root of both numbers. So, square root of 16x squared is 4x. I'm going to put a 4x there. I'm also going to put a 4x here. Square root of 49y squared is going to be 7y. So I need a 7y and a 7y. Close my parentheses. We know to make them cancel out perfectly, I need a positive and a negative. Okay, so now I have x squared plus y squared. Okay, so I'm going to do this, 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 right? Because that's the square root of each of those. And now if I put a plus and a minus here, well, let's double check. I'm going to get x squared minus xy plus xy. No, I don't want that. I want minus y squared, right? Because that's what happens when we FOIL it. So let's combine our like terms and make sure that we're back where we started. X squared minus y squared. Uh-oh. I started with x squared plus y squared. I ended with x squared minus y squared. Why does that happen? Well, because this rule is used for factoring the difference of two squares. And remember I said at the beginning, it only works if you are subtracting. On this one we were adding, so this one is actually not factorable. And that's how you factor the difference of two squares.